So let's start with the 15th problem. 15th problem says water flows in a horizontal pipe of non-uniform cross-sectional area of cross-section at a pressure difference of 1.6 centimeter of mercury. If the velocity of water at the larger cross-section of the pipe is 50 centimeter per second, find the velocity at the other end. Here I am going to use the Bernoulli equation, and since the pipe is horizontal, there is no effect of the potential term, so we can write P1 plus half rho V1 square is P2 plus half rho V2 square. This 1 and 2 defines 2 points of the different cross section areas. So we need to find out this V2. So P1 minus P2 into 2 by rho plus V1 square whole thing square root is basically V2, and if you write P1 minus P2 is given as 1.6 centimeter of mercury, we know that 76 centimeter of mercury represent 1 atmospheric pressure, that is 1.013 to 10 to the power 5 Pascal. So we have to use that fact, and we know rho is 10 to the power 3 for water. So V2 can be written as 1.6 by 76 into 1.013 into 10 to the power 5 whole thing multiplied by 2 by 10 to the 3 plus V1 square. Here it is given in centimeter per second, so you have to convert it into meter and you have to square it. So if you solve this problem, you just calculate this, you will get square root of 4.51. although there is no units are given, but it is in meter per second. Okay, now question 14 says figure out the case from the following in which the rope will break if an animal of mass 30 kg climbs on a rope which can stand maximum tension of 560 Newton. Assume G is 10 meter per second square. So suppose this is animal and this is the rope, the tension on the rope, and this is the force due to gravity. So since the animal is climbing the rope, so this must be equal to the acceleration of the animal. So T is 560 minus 30 into 10 divided by 30 is A, and if you calculate this, the numerator is 260 by 30, you will see it will come as 8.67 meter per second square, and if you truncate this to one number, then it would be 9 meter per second square, because this is greater than 5, the first number after the decimal. So in approximation it would be 9 meter per second square. Option B. Question 13 says that let the electric field of an electromagnetic wave is given as this, and compute the value of wavelength, frequency and the amplitude of the magnetic field part of the wave respectively. So as you know, the wavelength and the frequency of the electric and magnetic part of the electromagnetic wave, it's same, and the amplitude of the magnetic field is E divided by the speed of light, and the most general expression for E is E0 cos kx or in this case ky plus omega t into the direction in which the vector is pointing. So here this k is basically 2 pi by lambda. K is well known as the wave number and omega is 2 pi times frequency, which is known as the angular frequency, and f is the frequency, and we need to find out lambda, f and b. Okay, so we'll try to find out b first. So b is equal to 2.3 divided by 3.3 into 10 to the power 8. So as you can see, all the answers have a part 10 to the power minus 8. So you can write it like this, and this is less than 1, so you don't have to calculate it. The answer would be 0.76 into 10 to the power 8. Now you have to find out the frequency. Frequency is basically f is equal to omega by 2 pi. So here is the omega, 2.4 into 10 to the power 8. So this is 2.4 divided by 2 pi into 10 to the power 8, and if you calculate, the answer is 3.82 into 10 to the power 7. So only these two options are matching with our result we got, so we don't even need to calculate the wavelength. Okay, so option C is the correct answer. Now the question is, a stone of mass 0.3 kg tied to the end of the string round in a circle of radius 1.2 meter with a speed 20 revolution per minute in a horizontal plane. What is the tension in the string? And there is a second part, what is the maximum speed with which the stone can be whirled around if the string can withstand maximum tension of 100 Newton. So the tension must provide you the centrifugal acceleration due to the circular motion m omega square r. So omega is given in the details of this 20 revolution per minute. You have to calculate the omega. So 20 revolutions means 20 into 2 pi radian divided by 60 seconds. This is the angular speed, that is how much radian is traveled per unit second. So you have to calculate that would be 2 pi by 3, and you have to put here, that is 2 pi by 3 square into 1.2 meter, and you will get value of t as 1.57. So you don't need to calculate the second part, because only one option will match here, that is t is 1.7, option D. Question 11 says, which of the following statement is true for a wavelength of 100 nanometer? A PN photodiode is fabricated from a semiconductor with band gap 1.9 electron volt. So the thing is, when the light of proper wavelength, which has the energy of this band gap, falls on the photodiode, then only it can detect the signal, otherwise it cannot detect the signal. So basically we have to find out what is the value of energy of the photon that are coming, which has a wavelength of 1000 nanometer. So as we know, E is hc by lambda, and the value of hc in the units of electron volt nanometer is 1240. So you have to divide it with 1000, that will give you 1.24 electron volt, which is not same as 1.9 electron volt. So the photodiode will not be able to work, it will not be able to detect the signal. Option D is the correct answer. Now question 10 says the light from a point source in air falls on a spherical glass surface which has a n 1.5 and radius of curvature 10 centimeters. The distance of the light source is 50 centimeter. We have to find out the position of image. So we can use the formula for spherical surface, that mu by the image distance minus 1 by the object distance is mu minus 1 by the radius of curvature. So mu is 1.5 by v is 0.5 by 10 plus 1 by u, that is 1 by minus 50. Okay, so that is basically 1 by 20 minus 1 by 50. So if you do this would be 100 to 5 minus 2, so 1 by v would be 2 by 100, so v would be 50 centimeter. Since v is positive, it is in the direction of the incident light, so the image will be formed at distance 50 centimeter from the glass surface in the direction of the incident light, option B. Now question 9 says that a pulse of light duration 10 to the power minus 5 seconds is absorbed fully by a little object initially at rest. If the power of this pulse is given, we compute the momentum of the object. So here we have to use the energy momentum relation of the relativistic energy momentum relation, which is E square is v square c square plus m square c to the power 4. Since it is given that the object is very little, so we can neglect this term and we will write E as pc. So the momentum is energy by speed of light. Now energy deposited in 10 to the power minus 5 seconds is the power times the duration, which is 45 into 10 to the power minus 3 into 10 to the power minus 5 divided by 3 into 10 to the power 8. So this cancels with this with 15, and you have a 10 to the power minus 16 in the exponent. So option A is correct answer. Question 8 says that which of the following electromagnetic waves are used for detection in geyser tube. So this tube uses the method of ionization for detecting the electromagnetic waves. So for ionization you need high amount of energy, and since E is hc by lambda, so when lambda is small, energy goes up. So ionization will be performed by the wavelengths which is small in number. So X-rays has a typical wavelength of 1 nanometer to 10 nanometer. Microwave is in order of millimeter to meter. Light wave is 400 nanometer to 700 nanometer. Ultraviolet is less than 400 nanometer. So as you can see, the minimum wavelength has X-rays of these following options. So X-rays can be used for detection like geyser tube, option A. Now the question is, two spherical soap bubble of radius R1 and R2. They are joined to form a bubble of radius R. If surface tension of the soap is T, atmospheric pressure is P, change in volume of air enclosed is V, the change in surface area is A. We have to complete the expression given here. So we know that for a soap bubble, the internal pressure minus the outside pressure or the atmospheric pressure is 4T by the radius r. And when these two bubbles join to make a big bubble, the number of molecules in the bubbles must be the same, that is n1 plus n2 must be equal to n. And we'll assume one more thing is that the air inside the bubble behaves like an ideal gas. So this is P1 V1 by RT using the ideal gas law. PV is nRT plus P2 V2 by RT is P3 V3 by RT. Temperature remains the same, so P1 V1 plus P2 V2 is P3 V3. Now we have to use this formula where P1 is 4T plus R1 plus P. V1 is 4/3 pi R1 cube plus 4T by R2 plus P. 4/3 pi R2 cube is equal to 4T by R plus P. 4/3 pi R cube. Let me rub this out. So if you take common P into 4/3 pi R cube, 4/3 pi, then you will have R1 cube plus R2 cube minus R cube on the LHS. And on the RHS, if you take common 4T into 4/3 pi, then this R cube will cancel 1 R. So you have R square minus R2 square minus R1 square. And this whole thing, the change in area, so this is P minus PV because the final volume minus the initial volume, so you have to put a minus sign. That is equal to 4T by 3, and this 4 pi and R square minus R1 square minus R2 square is the change in area. So this is A, and this would be 3PV plus 4AT is 0. Option D. Question 6 is a stream of water flowing horizontally with a speed 20 meters per second pushes out of a tube of cross-sectional area 10 to the power minus 1 meter square and hits a vertical wall nearby. Find the force exerted on the wall by the impact of water. So in 1 second, the amount of water that is releasing from the tube is contained in a cylinder of length 20 meter and an area 10 to the power minus 1 meter square. So the volume that is coming out from the tube in unit second is 20 into 10 to the power minus 1, that is 2 meter cube. So it has a mass 2 into rho, which is 2 into 10 to the power 3, which is 2000 kilograms. So per second 2000 kilogram of water is coming out of the tube with a speed 20 meter per second. So it is coming out of the momentum m into 20, which is 40,000 kg meter per second, right? So the force is delta P over delta T. So in the interval of 1 second, the water that is coming out has a momentum 40,000 kg meter per second, and after collision the momentum becomes 0. So F is 40,000 divided by 1 second, so the force is 40,000 Newton, but in the official answer key it is given as option B. So if you know how to reach option B, then please write it in the comment box, but I think option A would be the correct answer. Thank you.